In the massive world of industrial engineering, with its sprawling pipelines and incredibly complex machinery, some of the biggest threats are the ones that are completely invisible. So today, we're going to dive into the really clever procedure that's designed to hunt them down, the pressure drop, or as it's often called, the hold test. Here's what we're covering. We'll start with the danger of those unseen leaks. Then we'll get into what a hold test actually is and walk through the procedures step by step. After that, we'll look at why this test is so critical, and we'll wrap it all up with the most important piece of the puzzle, safety. All right, so let's jump right in and set the stage. We need to understand the core problem we're trying to solve here, these invisible threats that are just lurking in our most critical industrial systems. So let me ask you a question. When you picture a massive pipeline or some complex piece of machinery, what do you think its biggest threat is? Is it, rust? Maybe some kind of external damage? Well, the real answer might actually surprise you. That's right, it's a leak you can't even see. These tiny, almost imperceptible leaks in welds or fittings or valves, they can lead to absolutely catastrophic failures. And I'm talking about huge product loss, environmental damage, and worst case scenario, major safety disasters. That is the invisible enemy we're hunting. So, how in the world do you find a threat you can't see? Well, that brings us to the solution, the pressure drop, or hold test. It's a method designed to find these exact leaks with incredible precision. At its heart, the idea is actually pretty simple. It's a pressure integrity check. You take a system, you seal it up tight, you pump it full of a gas or a liquid to a very specific pressure, and then you just wait and watch. If that pressure drops, even a tiny bit, boom, you found your culprit, a leak. The whole principle is brilliantly simple, really. It breaks down into just 3 key actions. First, you pressurize the system to a set level. Second, you isolate it completely, sealing it off from whatever you use to pressurize it. And finally, you monitor. The logic is elegant, right? If the pressure holds, the system is secure. If it drops, you know you've got a problem you need to solve. Okay, so we've got the theory down, but how does this actually work in the real world? Let's get into the practical side of things, the actual step-by-step procedure for doing this test safely and effectively. This is where it all comes together. A crucial point here, the test doesn't actually start with adding pressure. It starts with meticulous prep work. We're talking about verifying that every single gauge is perfectly calibrated for accuracy, making sure all the isolation valves are installed correctly, and conducting a full hazard analysis. You set up safety barriers, clear the area. This prep work isn't just a step, it's the foundation for a safe and accurate test. All right, once all that prep is done, the official test begins. First, pressure is raised gradually, you never want to do it suddenly, up to the target level. Then the system is completely isolated. This starts the clock on the hold period. Now this could be 10 minutes, could be an hour, it really just depends on the system. All through this time, technicians are watching high accuracy gauges for even the slightest change. And finally, you get the result, a pass or a fail, and every single detail gets logged in a formal report. And the results? Well, they're about as black and white as it gets. On one hand, you have a pass. The pressure holds steady, everything is stable. That means the system is tight and secure. On the other hand, you have a fail. The pressure drops, which is a clear signal that there's a leak somewhere that needs to be found and fixed. There's no gray area here, which is exactly what you want from a safety check. Okay, so we know what it is and how it works, but now let's zoom out and look at the bigger picture. Why this test is so absolutely crucial in so many different industries. See, the power of this test is that it does a bunch of things at once. It's not just about finding those tiny leaks. It's about verifying the integrity of the entire system before it goes into service. It's about preventing product loss, heading off potential disasters, and confirming that any recent repairs were done right. At the end of the day, it's about building confidence and ensuring safety. And you might be surprised just how widespread this test is. We're not just talking about huge oil and gas pipelines. This test is essential for everything from the process piping in a chemical plant to the hydraulic systems in heavy machinery, to pressure vessels, heat exchangers, and even the tiny instrument airlines that control much larger systems. A big reason it's so widely used comes down to its incredible versatility. That same core principle, pressurize, isolate, monitor, it works perfectly for both liquids and gases. So whether you're testing a hydraulic fluid line or a natural gas pipe, the physics of the test are the same. This adaptability makes it a totally indispensable tool. And that brings us to our final and maybe the most important section of all. Because when you're dealing with high pressure, safety isn't just a guideline, it's everything. You see, doing this test safely isn't optional. It's a strict, non-negotiable protocol. Instruments have to be perfectly calibrated because a bad reading could be dangerous. Full exclusion zones are set up to protect people from the stored energy in a pressurized system. The pressure is always built up slowly. And the really well-trained technicians even account for things like temperature changes, because on a hot day, a gas can expand and make it look like the pressure is rising. And most importantly, there's always an urgency plan to safely depressurize the system if something goes wrong. And this quote right here, it really gets to the heart of it. The entire purpose of a pressure drop or hold test is to provide certainty. It's the certainty that a system is leak-free, that it meets every compliance standard, and most of all, that it's absolutely ready for safe operation. So that leaves us with a final thought, doesn't it? The pressure hold test is just one of these amazing, invisible checks and balances that happen behind the scenes every single day to keep our complex world running safely. It kind of makes you wonder, what other vital procedures are happening right now, just out of our sight?